Hey everyone, this is our first video with this module. Here's our objective for the lesson. We're going to be able to add and subtract polynomials, write our results in standard form. So we'll talk about all those things. We'll walk through notes on this front side. On the back side, there are 10 problems to practice. Oops, don't see the answers. And then after you've done this and checked your answers, you should go on and take the quiz associated with this lesson to show that you've mastered it. Alright, so first I'm going to talk about, if we're going to write our results in standard form, I want to say what that is. So the standard form of a polynomial, if we have some polynomial, which is a bunch of x's, for example, here's an example, some x to the nth power, let me rewrite that, sorry, here we go. Here's an example of a polynomial in standard form. It would be x to the fourth plus 3x to the third plus 2x squared minus 10x plus 5. So I just made that one up. But as you can see, what standard form of a polynomial is that it starts with the highest power, x to the fourth, and then it goes down the line in decreasing powers. Then it becomes x to the third, and then an x squared, and then our x term, and then our constant at the very end, just the plus 5. So that one's an example where all of the powers are there. Something can also be in standard form if it doesn't have all the pieces. So for example, x to the third plus 4. If that's our polynomial, that would be it in standard form. Let's write that example 2. And then I'm going to make it a non-example. So something that's not in standard form is if you had a polynomial that looked like, non-examples, I'll do a couple. If you had a polynomial that looked like 2x plus 4x minus 3x cubed. Right? This example is not in standard form because it has two of our single x terms. We could combine those. We could make that simpler if we combine those. We'll talk about that in a second. Another non-example is if we have some kind of product in here. Like if we had x plus 1 times x plus 3. They're being multiplied, for example, or divided. This is not in standard form because it's not multiplied all the way out. This, we'll find out later, will multiply to x squared plus, let's see, that's going to be 4x plus 3. That would be it in standard form. And this equation up here, I could also write it in standard form. Negative 3x cubed plus 6x. So here we just talked about, like, what is the standard form? What are we thinking about when we ask you to write things in standard form? We want everything in highest to lowest power, from left to right, and any kind of things we can simplify, make better, like combining like terms or like multiplying out. We should do that so that we can get it in standard form. All right, that's what our output's going to look like. Now we're just going to learn the tools for today. The first one is addition. Ennis here asks us to write the sum of each example in standard form. So when I do these examples, I'm going to walk through an example. I'm going to pause the video and have you go on and try it. Just so that you have a chance to like test things out, see what's working for you, and then get to any misunderstandings clarified. Alright, we're adding polynomials. This will probably be one of the most straightforward skills. We really just need to, when we say addition, we're just like combining. I like to think of it as combining. Right? That if we have some quantity of things, we want to combine the like things with it. So here we have a 2x squared, and then we're just adding on a negative x squared. So the first thing I'm going to do is rewrite this without the parentheses, because if we're just combining our terms, we don't need the extra parentheses because we're just combining. So I'm going to first rewrite it without them. And then we have here, it has a plus, a minus x squared. Well, that is just a minus x squared, right? If I take away an x squared, plus 5x minus 2. So now I've rewritten it without the parentheses, taking care of that little extra minus sign there. Now I'm going to highlight our like terms in different colors. So in yellow, I'm highlighting the x squared terms. We're going to combine those terms because we're adding up. We're going to combine the x squareds because we can combine them. Then we're going to combine the orange x terms. And then lastly, we'll combine our constants in the blue. Alright, so if I do this in order, my first one's going to be a 2x squared and a negative x squared. Well, if I'm just combining, I have 2x squared, some from the left side, and I'm taking away, we like to think of that as 1x squared. So 2x squared minus 1x squared is just 2 minus 1 is 1. So 2 of this thing, and I took away one of them, and that just left me with one of them. In the orange, I see I have minus 2 x's and plus 5 x's. Alright, so I'm going to sketch myself a little number line just because I don't like to make mistakes on this. I'm starting at negative 2, and I need to get up to, I need to count up 5. So I'm just going to count up 1, 2, 3, 4, 5. 5 up gets me to positive 3. So I could use a calculator, I could use a number line, I could use whatever method you like to add negatives, but we just have to be careful to make sure we're getting positive 3 x's. I'm going to highlight those so we know where they came from. And then lastly, the negative 5 and the negative 2. I'm going to use our number line again here, except this time I got to go left. If I'm at negative 5, 1, 2, 3, 4, 5, negative 5, I got to go 2 left, negative 6, negative 7. Negative 7. So I'm really taking my time with the additions. Hopefully, if you have a calculator near you, if you don't feel confident, or you can just go ahead and use what you know by adding and subtracting to make sure you get your signs correct. All together, then we'll just make sure we write this in standard form. We have the option to leave this 1 on or not. I'm going to actually just write it with it off, just so you can see it both ways. X squared plus 3x minus 7. There's our nice tidy answer in standard form. We took the 6 terms at top, combined them to just have 3 terms in our quadratic at the end. Alright, so at this point, it'd be great if you could pause the video, move on to example 2, and try it out really quick. It shouldn't take too long. It's a pretty simple extension of what we had here. There may be some additional challenges as we see, though. So pause, try it out, and we'll come back together. Alright, so hopefully you've tried this one out. In number 2, I'm going to go back to my highlighting ahead of time. Actually, first I'm just going to rewrite it without the parentheses because we don't need them. X squareds plus 3x plus 2 plus 5x squareds minus 3x minus 2. Now I'm going to highlight my like terms. My squareds in yellow. My x's in orange. And my constants in blue. I'm going to combine my x's first. I have 1x from the left and 5 of them from the right, so that's a total of 5, 6. 6x squareds. In orange, I have 3 x's and I have take away 3. Well, if I have 3 take away 3, that's the same as having none. No x's. So I wrote plus 0 x's. Basically, we'll find we're going to write it without the x term, but there's none of them right there just so we can keep track. And for constants, same thing. I have 2 of them, take away 2, that's 0. I have none left over. So I'm keeping track of each term that I could have, but then in the end we'll be able to rewrite it. I can get rid of anything with a 0 in it because it's not actually contributing anything, so I'm just going to go 6x squared. That's my final answer. Alright. We have 2 more examples of this. I'm going to step through them. They introduce a little bit of complication. Then we'll see with subtracting, it's actually very, very similar, so it's not a lot more left. Alright, example 3, we have two binomials here. We call these binomials because they just have two parts, two pieces. I just need to combine my like terms. Well, for the first one, I'm just highlighting this first term, this x term in yellow. Then I'm looking for any other x terms that I could combine. I don't see any more plain x's. I see an x squared. I see some constants, but I don't see any more x's. Actually, there's nothing else to combine there. I'm going to highlight my constants now in orange. And I guess I'll just highlight my x squared. And it's a positive x squared. So I guess now all I have to do is combine any like terms, which is just the contents, and then put it in standard form. So I'm going to make sure I put my x squareds first because that's my highest power. It's positive and there's one of them, so I'm just going to put my x squared term first. Nothing to combine it with, so I can just leave it alone out there. Then next my highest power is going to be x. I'm going to do that in yellow. It's positive x. And then finally my constants actually can combine. I have two of them and I have to take away one of them. 2 minus 1 is positive 1. So altogether I can just write this as x squared plus x plus 1. So in this example we see that there isn't always something to combine with every term. We just have to be very careful and match up what we can combine. Alright, this last one is just a different way of asking the question. First of all, I'm gonna outline this in red. So f of x is in red. It's an x cubed plus 2x plus 1. And then it gives us a g of x. I'm gonna outline in blue. It's an x squared minus x minus 4. And then it says find f of x plus g of x. So, this is really just asking us to add up these two expressions, but it didn't write it out explicitly. So we're going to do that first. Whenever we have to find something we need to plug in for, here we're going to be substituting the expression on the right side in for the f of x in our product. So I'm going to write this out. F of x plus g of x is going to be in blue. So I'm going to have my f of x expression in red, my g of x expression in blue. And I open parentheses to keep them separate. Now I'm going to write out my f of s expression. Well, it's going to be x cubed plus 2x plus 1. That was my expression from f of x in red. In blue, I have my x squared minus x minus 4. Great. Now I've written them both out. I'm highlighting my like terms next. This problem, this red and blue, looks just like the problems we're solving above. We have two polynomials being added together. We just have to combine our like terms. In x cubed, I don't see any other x cubes. As I was looking across, I started to highlight in yellow and I don't see any more. So I'm going to stop. The next highest problem I see in this whole... Next highest power I see in this whole problem is an x squared. Then I see my x's. And then I see, after all that, my constants. So this has a lot of different terms in it, but not all of them are combined. It looks like x third is my highest, x to the 3. I'm just going to leave it out front. Nothing to combine it with. It's positive. Then next highest should be an x squared, and sure enough, yep, I have that one in orange already. So plus my x squared in orange. In blue I have an x, my x's, I have a 2 and a minus, that's like a minus 1, so that's a 2 minus 1 is 1, so plus 1x in blue. And then in pink I have my constants, negative 4 and 1 is negative 3. So then I'm just going to write it without the colors, kind of simplified. X cubed plus x squared plus x minus 3. Be our final sum. The last problem we just introduced a different notation. Really, it's just asking us to add up two polynomials. Okay. So we know how to do summations. If you feel like you'd like to practice this now, before we move on to learning how to subtract, what you could do is you could go to the back side in this practice. I don't want to show us the answers. And pick out any problems that are asking you to add, and then go on and practice those out, just so you have it all fresh in your mind before you go on and learn about subtraction. Otherwise, if you feel like that was pretty easy, I think that subtraction is a nice contrast to talk about next. Alright. Notice in all these examples, I actually just changed the plus sign in the middle to a minus sign. So all the numbers, all the expressions are the same, so we'll be able to compare adding and subtracting. Alright, so in subtraction, there's one extra step. In addition, we just had to add on each of the terms in the right. So we did plus negative x squared, we did plus 5x, and we did plus negative 2. And we added those things together. In subtraction, we're just doing the inverse. Instead, we're subtracting each of those things. So the first step I like to do to make sure I don't forget is I'm going to think about what I'm doing is I'm take away each of these things to the right over here. I'm taking away a negative x squared, I'm taking away a positive 5x, and I'm taking away a negative 2. So in this step where I rewrite my expression, I'm first going to take this expression, nothing's happening to it, it's still there. But then for each of these pieces, I have a negative, I'm taking away the piece from the right term. So it's going to be a negative x squared. When we have minus a negative, that's the same as adding. So this is going to be a plus an x squared. So this is the only difference in subtraction, is that for each of these pieces, I'm taking away instead of adding on. So for the next piece, it's going to be minus a positive 5x. Well, that's just minus 5x. For the constant, it's going to be minus a negative 2. Minus a negative is a positive 2. So the contrast here is I had to subtract all of my pieces, but then the rest of our work is really just going to be combining these like terms. Once I've taken care of the negative, now I'm just combining our like terms because I've already subtracted everything off. If I go on with that, for my yellows, for my squareds, I'm going to get a 3x squared. In orange, I have negative 2 and negative 5. That's negative 5, negative 6, negative 7. Negative 7x. And then negative 5 plus 2 is negative 3. Yellow. Orange. Blue. So, let's look at the difference between addition and subtraction. Because in example 1 and both, I had the same expressions, 2x squared minus 2x minus 5, except instead of adding it, I subtracted it, and we ended up getting very different answers. I'm just going to highlight in pink these two answers and how different they are. Right, my x squared term is a 3x squared instead of an x squared. I have a negative 7x instead of a positive 3x, a negative 3 instead of negative 7. So we have to be really careful to take that first step and distribute our negative. That is going to be the common mistake that we make. I forget sometimes too, but we just have to remind ourselves. As soon as we see a negative, I want to like, well, that's a negative I care about. I need to distribute it to all of my pieces to take them away. So I write out those arrows to remind myself, and I rewrite the problem so I don't forget. So we got x squared plus 3x plus 2 minus a positive 5x minus 5x squared minus a negative 3x minus a negative is a positive 3x, and for the 2 again it's a minus a negative, so that's a plus a 2. Combining like terms, and if you have a highlighter and it helps you to do this, to highlight the like terms so that you know which ones to combine, definitely take advantage of that. X squared minus 5x is minus, that's like a 1 minus a 5. 1 minus 5 is minus 4. X squareds are oranges, that's a 3 and a 3, both positive, so positive 6x. 2 and a 2, both positive, so 4. Again, I'm moving quickly through these because we're really repeating a lot of the same process. You should always feel comfortable to just pause the video, ask yourself some questions, or think to yourself about what's going on, and let it continue. That's what's great about these videos, is you can go at your own pace. Alright, let's now look at example 3. Just like before, I see a negative here, and the parentheses, I'm subtracting everything inside this quantity over here. I'm subtracting an x squared, and I'm also subtracting a negative 1. So first I'm going to rewrite it. X plus 2 minus x squared minus a negative 1 is plus a 1. I only see the 1x. There is an x squared, only the 1 though, and then there are 2 constants. Okay. So if I want to write it in my standard form, which is what we're supposed to be doing here, and put my highest power first, which is my x squared. So we put negative x squared, that's biggest. Then my positive x, yellow. And then in blue, our constants become 2 and 1 make 3. So write this separately. Oops. Negative x squared plus x plus 3. Great. And this last one, you should pause and try it out. It looks a lot like the last one with the other example 4, where we have our 2 quantities and we're subtracting them. It's going to be really important here that we plug them in first and subtract. So you should pause the video, try this one out, and then we'll come back together. So hopefully you pause this. I just made a note of these parentheses that show where I'm going to put my f of x expression, which is all in red, and my g of x expression, which is in blue. Alright, so my x cubed in red, my 2x, and my plus 1. And then for g of x, it has an x squared, a negative x, and a negative 4. Then there's a negative sign here, so I gotta make sure I distribute it, so it's gonna be subtracting each of the terms in that verse. We rewrite it to account for the negative. X cubed plus 2x plus 1 minus x